Hello, this is Gregory Minkovsky with technical presentation for RMS project for International SOS, and this is a presentation of a proof of concept for Azure migration project. We have on-prem .NET C# written API application called RMS. This is Healthcare Claims and Referrals Management System, which has WCF endpoint accepting HTTP post requests from external client, which we have no control over, and we need to keep the input request structure intact, including that being WCF. Namely, there is EDI message in it, wrapped into SOAP envelope. So this slide shows you the existing system. External WCF client consumes our WCF endpoints application running on-prem in IIS. It is a C# written application. It has a big C# EDI parser. It writes text logs and it writes the database SQL Server records and then sends that information further to other systems. And this is a proposed system which is gonna be in Azure. It's gonna still have the same calling WCF consumer client because it's not under our control, it's outside of our company, and the request gonna come to Azure App Service or to LogicApps receiver directly, and it should still write some logs there, and it should write to the database, which is gonna be Azure SQL database in the cloud, and then we are planning to do the LogicApps workflow, which is gonna decode those messages. That's gonna be some kind of parser for EDI, which comes in SOAP. So we need to separate that SOAP from EDI and parse this EDI in the cloud without C# parser this time, just using the standard XSD schema for this, and also save these parsed values to the database and send that information further, proceed to other systems. Okay, now this is a request structure. This is a snippet from the Postman. You can see that there is a SOAP envelope in the body. There is request. It has body. It has a referral ID parameter and also see data commented EDI code. This is a special standard for healthcare messages B2B, and it has that referral ID in a couple of places inside of it and some other information. So we need to parse this EDI, and that's what the application does. The RMS C# on-prem WCF system parses this. There's a big parser written, and it fetches data into the database, logs it, and does other processing further. Now this needs to be moved into Azure cloud so that we should not use those C# parsers. Because if EDI structure changes later, we don't want to keep changing the parser. But we should use the standard X12 schema to parse this EDI, and let's see how it's going to do it. This is the same request but showing headers. Some of those headers we do need for the LogicApps, especially this S22, S2 from, because they are identifying the partners. You see host partner and guest partner. We need those later in the portal, in agreement, in the integration account. The content type is text XML. SOAP action is very important too. This is the name of the endpoint. Submit to 78 request is the name of the function in that API, in our WCF endpoint. Now also take a look at the URL. URL is HTTPS, and it has that prod 13 US government Virginia logic Azure US. Virginia is the name of the resource group location in the Azure cloud, and US Gov shows you that this is a government cloud. This is not a general Azure account. This is the LogicApps entry point URL, which you can see in the LogicApps designer, but we'll talk about this workflow later. You're gonna see this URL in the portal a little later. And this is the same request sent to localhost. You can see this referral web service.svc. This is used just for debugging when Postman sends this request to the local host, and obviously we don't need the extra headers like as2 to, as2 from, and we only need content type and SOAP action. You can see that the SOAP action is the name of the endpoint, the function which you are going to test. That's how it finds the function in C# code. This is one more look at the request. So this is the WCF endpoint submit to 78 request. You can see that it accepts object. This is a service contract. You can see this function submit to 78 request here with the interface. And then there's trace.indent. This writes the trace file, and this happens in Azure also, because later this application has been moved into Azure and it works both local and in Azure. Then you can see that I had to replace the caret sign with some letter like U here. That's because for some reason EDI parser in LogicApps did not like that caret sign. In the agreement, X12 schema does not like this sign, makes an error. So I had to replace it, that particular sign, just on single occasion in that EDI. This string EDI data is already cleared from SOAP. It's just plain EDI. And then you can see it inserts request into history table to the database asynchronously. This task.run function, that's the initial request gets inserted, the EDI of it before parsing. And we're talking about both on-prem database and the Azure database. Whatever DB connection string you use, you're going to see that LogicApps also inserts into the database, but already after EDI parsing. And then you can see the process transaction function runs. In that function, it creates new request, new HTTP request to send it to LogicApp. And so the body of that request is going to be that EDI string without SOAP. It resends the received message to the LogicApps. So it works as an endpoint, but further pushes it to the LogicApps receiver. And here you can see that it creates another request with those headers which were there in our Postman test, but they are not in initial request. But we need those headers there. So it puts together a new HTTP request. You can see as2 to from and some action headers. Then it sends that request to LogicApps and gets a request stream, the response back from LogicApps. Now this is already a portal in Azure. Here you can see that this is a Microsoft Azure government account, and these are the objects. The globe RMS is that C# API WCF published into Azure. This is called App Service in the portal. It's located in our ISOS resource group. Right now it's disabled here, sitting on a subscription which has this GUID ID. We can adjust authentication and TLS SSL settings. Can also add logs and diagnostics here. This is how you publish it. You can see it publishes it to the Azure URL of the app service. Then ISOS LA is going to be our main LogicApps workflow. ISOS IA is an integration account. I'll show you later. ISOS as2 send is a testing LogicApps, which I used to test the first ISOS LA LogicApps within the same Azure domain by sending request from one LogicApps to another just to test it. And you can see the parts of the URL, very same URL we used in Postman and in app service. And then you can see familiar headers, and the body is the EDI string. And next one is WCF endpoint LogicApps. This is also for testing. There was a question, can LogicApps connector be WCF without the need to publish the C# code, the endpoint, which I just showed you? And I did not experiment with it yet. It is possible to create custom connectors, and they can be SOAP to REST and SOAP pass through. Accepting the SOAP envelope message, we need to double check that because it may allow to eliminate the app service object. And yet the proof of concept works now with app service, so we have accomplished something already anyway. And a few more objects. We have the ISOS is the resource group, general storage place where all the objects are stored here. LA test is just another testing logic app. We can delete that. The ISOS subscription is like a key thing around which everything rotates. If that subscription gets disabled, if we don't pay the bill, then everything stops working. And the WPS store is the Azure database. Portal shows you its name, its SQL Server name, its connection string, its storage space. But to see the tables and procedures, you need Azure Data Studio or Visual Studio or SSMS. And Azure Blob is just a blob to experiment. You can see that we can delete half of those objects that for testing purposes this is gonna cut the price. I just disabled them for the time being. Now let's see the workflow. This is the top of the workflow. When HTTP request is received, that's the receiver. It pushes it further to decode X12 message connector, which does the decoding, and that's the whole thing there. I'll show you later how it does it. Then this checkmdn expected, there's a logic in it. It expands here. That sends OK back if the structure of request is OK, or failure it sends back if not OK. Then there is a loop. This initializes the two variables there. This already picks up the result of the parsing done in decode X12 message connector. After initializing variables, there is a for each loop, a compose. You can see the ISA 13 and GS04. These are already fields taken from EDI. These are parsed values. They're assigned into those variables in the loop. And then variables are set and then they are saved into the database. This is calling execute stored procedure. I created stored procedure there, sp azure la test insert. It just inserts those two values into the table, puts together JSON to wrap those parameters correctly and give them as arguments to that stored procedure in Azure SQL database. So as the request is received and passed to the decode X12 message connector, its body internally gets directed to the integration account, which is linked to the subscription, and you can see it's connected to X12 connection. This is connection to integration account, which does the parsing. Let's see how that happens. The request which comes here does not have SOAP envelope. This body only has EDI message. There is a way to separate EDI from SOAP inside of this workflow because there are XPath queries there, and it worked. However, because I used C# receiver, the RMS app service, I just did the separation of SOAP from EDI right in C#, and when building the new request, it built it just with the plain EDI. Again, this can be done in LogicApps as well, but why should we when it's pretty easy to do in C#? Yet we're gonna do it if we're gonna have a WCF pass through SOAP connector here, receiver of initial request. So this is an integration account. It has some schemas. Well, it has 4 schemas here, but we actually use one. I was experimenting, inserted there a few schemas. There is one agreement and there are 2 partners. Let's see what that is. But the important thing is that there are 0 maps. We don't really need any mapping. We need mapping only if we are doing something custom, meaning this the schema I was using is X12 278 standard schema I got from Microsoft BizTalk set of schemas. I'm gonna show it later. It's a standard one, but if we wanna customize the mapping, then we need to do some maps here. Right now it parses without maps successfully. This is the agreement. It's pretty straightforward. One single agreement named X12 agreement because it's of X12 type. I was also trying to use AS2 type. AS2 is just any generic B2B communication, but for our purpose, this one X12 is specifically for B2B in a healthcare way to parse using those schemas. And it has to have two partners, a sending partner and a receiving one. So I call them host partner and the guest partner. And these are identities of them, which are also important. This ZZ comes from EDI. It is part of the EDI. Once you set up as X12 agreement type, it's gonna know this ZZ tag in it, and it's gonna find it in the EDI. But you need to know which tag to give it so that it will identify the host and guest. So these are the partners. This is a guest partner. You can see the qualifier is picked up as that mutually defined SPI NSYS partner. It's a health industry number, and this is that ZZ mutually defined qualifier is the one that's active, not AS2 identity. I was actually playing with the AS2 connector, so I have this AS2 identity there, and also health industry number 20. I played with it, but they're not active right now. You can have only one agreement, but partners are created separately from agreement. And in different agreement types, they have different qualifiers. And I've changed agreement type from AS2 to X12 type at some point. But partners have some leftover qualifiers from previous agreement type. They are not active, for it knows which qualifier to pick up for this agreement type. I go back to agreements. You see here on the bottom there is receive setting and send setting. These are important receive settings. Once you click on this receive setting, let's see what that is. Here in the receive setting you set up if you need some authorization for the request. Well, here there is no authorization. It's pretty straightforward here, but we can put some security into here. And this is a schema section highlighted yellow. You can see that standard approved schema 501 version. That's the XSD schema which I took from the BizTalk package. And this is transaction type 278 healthcare services. And this is the schema name there. Comes up from this drop down because it recognizes that. And the second item 278 is also coming from the drop down. Now remember the integration account has schema section in it. Let's see what's in it. These are a few schemas which I loaded when experimenting. The one highlighted yellow is the active one because its name is used in agreement receive settings, which you just saw. And now it has content link. If you click on this link, you're gonna see that schema. Here I just open that schema in Visual Studio Editor, and you can see the top of it. That's the schema name X12 501 278. 278 is for claims and referrals processing. On the right side, we can see all the nodes in this XSD file. This is Microsoft schemas. A link on the top. See this? BizTalk 2005 schema editor. This is the zip package of different schemas, which is downloaded from Microsoft BizTalk site. And one of them is the one we need, X12 501 278 XSD schema. So when we send request in, that X12 connector passes it to the integration account, and the schema somehow automatically inside of it, it parses that EDI. Let's see. This is the run history for this LogicApps workflow. You can see on the left side multiple runs which I was doing, and so many of them were successful lately. And this one is on the right side. The last one of them is opened, and you can see the green circles, check marks on the corner of them on the right side for every step of the workflow, which means every step was successful here. Let's look at what happened inside of the decode X12 message connector. You can see that it has input and output, and you already see the EDI coming as an input. Let's click on the show raw inputs, and you can see that the body contains there's just a plain EDI. Like I said, there's no SOAP in it. It's already filtered out by app service, our C# endpoint. But it could be done in LogicApps using XPath expression. Now let's go back to decode X12 connector and let's see the raw output of it. And voila! Here we see the parsed EDI. Take a look. Well, this has good messages. Bad messages has the whole parsing. Bad because it doesn't like some leading and trailing spaces in EDI. EDI fields. You will see. You see this ISA05 has ZZ index in it. That's the indication of the sender. And that's how this connector inside of it, the integration account, identifies the partner. I use this GS04 in the functional group envelope. There's GS04 2016-06-27. That's obviously the date. So I use this particular field to take from here. It comes from so-called GS segment of EDI, and a little above you see ISA 13. That's the referral ID. So we need these two parameters. I use them to pass them to stored procedure. Extract from the EDI using for each loop, assigning them to variables, but we can use object to assign, and for each is used because there are multiple segments in this EDI, so it loops through them. This shows you ISA segment on the top, and I did not like the tilde mark. Okay, so we got parsed EDI. This is the top part of the output. You can see the headers here. There's a date, there's a content type is application JSON, there's content length, there's X powered by ASP.NET. We should probably remove that for security reason. Remember, this is coming from our C# app service, so we control it. And this body also has interchange control number, which is referral ID. Okay, and then goes good messages and bad messages, and because there are multiple fragments in it, so further workflow control, which takes this output, automatically creates the for each loop, because it takes section by section. But there is also a way to assign the whole EDI parsing result to the object and treat it even smarter. Now, this is the bottom part of the output. You can see there is a guest partner, host partner, there is a receiver qualifier, sender qualifier. So that's how it identifies them. There is also exception here. Error encountered, X12 transaction set with ID contained in functional group with ID. It doesn't like some leading or trailing spaces found in some of the elements. That's what made that record bad. We can fix that. And also you can see the payload here is an encoded string. And this is a message type. It tells you what kind of schema is used. But this encoded payload, we can decode it. So here I've pasted this whole encoded string into the base64 decoder online website, and once it decoded, we can see the different tags. We can actually see those EDI values here with the tags which are being interpreted by the XSD schema. You can see the actual values from the EDI here, like that date and like this referral ID ending 1999 from the request. Okay, so this is great stuff. We got the EDI parsed, and now we go down the workflow chain. Again, I initialize variables, assign them in a for each loop and compose section. This can be done in a smart way with object assignment, but then here these variables get into stored procedure as argument. You can see the connection settings, RMS database, US government cloud, .NET, that we can see in the portal. That's a characteristic of this database, and that's part of the connection string. I'll show you later. ADS uses that to connect also. And there's a stored procedure SP Azure LA test, gets an argument referral ID, and this is an output. Let's see. In this case, this stored procedure just takes this referral ID and finds the right record in the database and then does a simple select from it, meaning it gets the record from the table by this referral ID. And this is the raw input. We can see the referral ID here as in the body, and this is the raw output, the result of the select statement. These fields from the database table, which is the right record for this referral ID. You can see all the fields here. Then you can use them further in. You can run another stored procedure, pass that in the request further to another system. I changed that to the insert stored procedure, and I got that record inserted to the test table. Now let me show you. This is the Azure database which I made there. You can see on the right side there is a server name that's used for connection as a connection string. There are different parameters. It's a small one, you can see 32 megabytes. That was still online back then when I made that image. And this is the Azure Data Studio, which is free to download, which is connected to that Azure database. You can see on the left side stored procedures which I've made there, and a few tables. These are a couple of procedures I took right from our on-prem server, and you can see NC RMS 278 in the history table and 278 auth table. These are from our on-prem server recreated up there in Azure, and those stored procedures also. Plus I made a few test stored procedures. See, Azure LA test and Azure LA test insert, and on the right side there's a create procedure statement. Simple select finding record by referral ID. Okay, and this is a table. Now just show you a couple errors I was getting when testing. This is one LogicApps sending request to another LogicApps. You can see there was a bad gateway. It's worth to mention that currently this URL in LogicApp works HTTP and HTTPS. There are web config settings which enable HTTPS there, and we can turn the HTTP off. This was testing it. And this one error I was getting in Visual Studio at some point when it was not recognizing the subscription. But you can see on the left side there is a Cloud Explorer here, shows you all those objects from the cloud, and you can see the log files here. Remember the trace.write statement, it writes into here, and you can open those log files here, and also you can open the LogicApps designer from Visual Studio here. Well, in this case it didn't work, but at some point it was working. Also it was in and out based on the subscription status. And the way you deploy this RMS app service to the cloud is by using publish upon this account. You have to be logged in from Visual Studio into that Azure account. Now there is also utility page in a portal which allows you to see the files in a log, all those trace messages you put in. Now this is what happens in a database with a connection. You can't log in when subscription is disabled. Now this is a fine working project when subscription is active. So let's see what's the cost of it. Now this is billing record here. It keeps two accounts for you. One is a subscription account. Currently it's disabled here. And another one is the service account for developers, to help developers. All right, now it's active, so I was communicating with Microsoft over this active development account. This subscription is pay as you go, and this is tada, the invoice they send me. However, you can see $828. This can be cut, I believe, maybe to 600, maybe 550 or something, because again, look at that, all those subjects again I've created there. This highlighted yellow we don't really need. I can delete them. They're just used for testing, and this might cut some price. Plus remember, you migrate all these systems into Azure, you're gonna save on data center, on supporting all those on-prem servers, which is a much bigger cost. Well, it's up to management, of course, to decide, but put this number next to the service price for the on-prem servers and data center rentals. One more thing, Microsoft said whatever has already been built not gonna be lost, because this account can be easily transferred to a company account. Change the ownership of it. Thanks so much for your attention, and I hope to work with you together on this.